This is Jessica Dunn, and we're going to be discussing capital budgeting technique. In particular, we're going to be looking at the internal rate of return. The internal rate of return is a very popular method. It is just as popular, if not more popular, than net present value. However, it's not quite as good as net present value in getting accurate answers, and we'll discuss that later, but it is very sophisticated. It's a sophisticated budgeting technique, and this internal rate of return tells you the discount rate that equates the net present value of an investment with $0. So it tells you that the minimum rate of return that the project that the it tells you the rate of return that the project will earn if it invests in the project and receives the cash flows that are expected. So if the internal rate of return is greater than the cost of capital, then you would accept the project. If it's less than the cost of capital, then you would reject the project. So this guarantees that the firm will earn at least its required return. If the projects are independent, then you would accept all projects where the internal rate of return is greater than the weighted average cost of capital. If they're mutually exclusive, then you would accept the projects with the highest internal rate of return, assuming that the internal rate of return is still greater than the weighted average cost of capital. So let's look at two projects. We have project A that costs $42,000 and yields $14,000 for 5 years, and we have project B that costs $45,000, earns $28,000 in year 1, $12,000 in year 2, and $10,000 in years 3 through 5. So for calculating internal rate of return, we need to employ the use of our cash flow register. So push your cash flow register. Cash flow at time period 0 is a negative $42,000. So the cost will pay for that. Cash flow at time period 1 is $14,000, and that occurs 5 times. So once you do that, you push the IRR button, enter down compute, and you get 19.9%. So let's see how it looks on our financial calculator. So when I open up the cash flow register, let's do second clear to clear everything out. This project costs $42,000 and returns $14,000 a year for 5 years. And you do have to push enter to save after the frequency. So push IRR and compute, and you get 19.9%. So let's do the same thing for project B. Again, we're going to use the cash flow register. Cash flow at time period 0 is a negative $45,000. At time period 1, it's a $28,000 with a frequency of 1. Cash flow at time period 2 is $12,000 with a frequency of 1. And cash flow at time period 3 is $10,000, and that occurs 3 times. Push IRR and compute, and you get 21.7%. So let's work that on our financial calculator. First, push the cash flow register button. Then second, clear work. Cash flow at time period 0, this project cost us $45,000, so enter to save. In year 1, it returns $28,000, enter to save. That occurs once. Cash flow at time period 2 is $12,000, enter to save. And notice that the default frequency is 1, so as long as it's 1, you don't have to push anything. Cash flow at time period 3 is $10,000, enter to save. Scroll down, and that has a frequency of 3, so enter after I put in the 3. IRR, which is right next to the net present value button, and compute, and we get 21.7%. So according to internal rate of return projects, B is better than A because it has a higher internal rate of return. Now, internal rate of return has a little bit of problems with it. So when we're ranking projects, we always go with the ranking that is given by net present value approach. However, internal rate of return and net present value will always give you the same accept or reject decision. So if net present value says that it's an adequate project, that the net present value is greater than 0, internal rate of return that is going to be greater than the weighted average cost of capital. So they're always going to tell you yes or no correctly, but the ranking of the projects is where we sometimes get into trouble with the internal rate of return approach. So project B would be better than project A. So if we had mutually exclusive projects and we were using internal rate of return, we would accept project B over project A. If we had unlimited capital and they were independent, we would accept both. So it's interesting that project B has a higher internal rate of return than project A when net present value said that project A was better than B. Conflicts like this are normal. We see it all the time. There's no guarantee that net present value and internal rate of return are going to rank projects in the same order, but they always come up to the same conclusion on acceptance or rejection. So why is net present value better? So if we have a 10% weighted average cost of capital and we have a large project with an investment of $100,000 that returns $50,000 a year for 10 years, or we have a small project where you invest $1 and returns 60 cents for 10 years, if we were to calculate the internal rates of return and the net present value, we would see that internal rate of return prefers the small project. It prefers a small project. Whereas net present value looks at this and says, well, obviously the large project is better because if we can't repeat this project and have a $1 million investment with a $600,000 return, it's not really worth our effort. Instead, let's invest $100,000 and receive this large sum of $50,000 for 10 years. So internal rate of return prefers smaller projects. So even though large project is better, internal rate of return would tell you the small project is better. Now with the cash flow pattern, normal cash flow projects are where we have a cost, so a negative cash flow followed by a series of positive cash inflows. So there's only one sign change. A non-normal cash flow project is where we have 2 or more sign changes. So we might have a cost, then cash inflows, and another cost. So example would be if we were mining. It would cost you money to open that mine, then you would receive cash inflows for years, and then once you close, the EPA would have you clean that mine back up, so you would have an expense associated with that. So normal cash flow, we have a cost followed by inflows. There's only one sign change. Non-normal, we have multiple sign changes. So cost, inflow, cost. This would also be normal here, where we have a series of costs. It takes us multiple years to get the project up and running, but then once we do, it has cash inflows. Another normal would be a series of inflows, then followed by costs. So only one sign change again. And then non-normal is the final line. So let's look at this example here. We have a project that costs $800,000. It returns $5 million, and then it costs $5 million. So if you enter these cash flows into your cash flow register and your discount rate is 10%, net present value is going to give you a negative number, so negative $386,000. Internal rate of return is going to give you an error. It's going to give you an error because, or if it doesn't give you an error, it depends on what kind of calculator you have. If it doesn't give you an error, it's going to give you only one internal rate of return, whereas this project would actually have 2 internal rates of return. It would give you the lowest internal rate of return. But because there are 2 sign changes, there are 2 points at which the line passes through the $0 net present value points, and so there's actually 2 answers to this when looking at internal rates of return. So for every sign change, you get an additional IRR. Your calculator is either going to give you an error or it's going to give you the smallest one. So you get two IRRs, and when more than one solution exists, the calculator is going to display the one that's closest to 0. If there are multiple IRRs, then it's best to use net present value.